What's up, guys? So today we've been called in to kind of clean up a bit of a mess. We've got a bunch of mineral and gem specimens here, but there's no order to them. They're all in a jumble, and we have to sort them from A to Z and try and make sense of this giant clutter. I've got a little stack of sticky notes here so we can stay a little bit organized and on top of things. Well, I'm gonna write A on this one, and let's get this show rolling. I see a couple of things.
There's a lot going on.
So I kind of am tempted to go out of order.
Going ahead and writing the letters down might be a little bit easier.
So now that we've got our letters laid out, do you just want to start like independently homing them and then checking each other when we think that we're maybe incorrect?
Sure.
Okay.
Why not?
So I would bet a not insignificant amount of money that, we've got the same thing. You found one as well. I think this is fluorite.
Right here. Yes.
Yeah, fluorite? Yeah. Okay, all right. So, all right, we're in agreement. Mine has a cool little color zone here. It's got like a triangle of colorlessness.
There's some color zoning in this one, but it's not as cool as that one.
But it is way bigger. Put our little octahedrons up there above F. Okay, cool. I feel good about that. We've got F locked in.
A for Alexandrite.
Oh, really? Okay.
Yeah.
What makes you think that that's an Alexandrite?
There's some kind of trilling going on. Trilling is a term for, imagine, I think it's 3 weird V triangles together in a spokes wheel kind of pattern.
Mm-hmm. I know what you're talking about.
Yeah, the very top of this is kind of like that. Also, the fact that it's just a really, really dark green.
What you got?
Got some Chrysocola over here.
Oh, nice. Chrysocola does typically have this almost turquoise color to it. It gets mistaken for turquoise a lot.
A lot of the veining and patterning kind of similar to turquoise. It's not quite there like as hard or as defined lines as the veining that you see in turquoise, which is usually sometimes the matrix of the rock that it's holding in, that it is in.
Did you also know that Chrysocola has a varying hardness between 2.5 and 7?
I did not.
Isn't that crazy?
That's crazy.
So don't go scratching it because you might actually. All right, what else do you see? Sorry, I'm going to answer that myself because this color is surely only one thing, right?
More or less.
I think it's dioptase.
I would agree with you.
Okay. And I think we have more than one because I've seen it around. This guy also, I would say, is dioptase. And this one that does not say dioptase on its stand is also dioptase.
Agreed.
All right. I think we've got 3D. 3D. Okay, let's keep going. I know this guy. This is an ammonite fossil. It's an ancient cephalopod that would scuttle around in the ancient seas. And when it died, its shell settled down on the seafloor and it was covered up by sediment and became a fossil.
Yes.
However, most fossils are typically replaced by like quartz, agate. I think I've heard of calcite as well, being a typical replacement for fossils. This one has been replaced by pyrite. So this is a pyritized ammonite fossil, which is it's like a shiny Pokemon in real life, which I think is really cool. So I think this is, since we've already got an A, I'm gonna say that this is P for pyrite.
I'm gonna move on to this blue guy right here. So this is Sodalite. And Sodalite is one of the neat minerals that also forms in the cubic crystal system. Sodalite is one of the potential minerals that can form in lapis lazuli.
Oh, okay. Yeah, I was going to say it looks a lot like lapis, but it is not lapis.
Well, no.
No. It forms in the sodalite group with lazurite.
Yes.
I think this is wolfenite. I think that because it's like yellow-orange, and it's got these big, distinct tabular formations.
Yes.
It can also be prismatic or pyramidal, but because of the color, I'm gonna slot this in at W if that's cool.
Nothing like a U to go with the W.
Okay, what is that guy?
So this is unakite. So within unakite, the majority of what makes it part of a rock type is the green is epidote, the pink are types of feldspars, specifically with potassium content, which causes the pink color. There can be quartz in here as well.
Okay. Go ahead and slot it into our U position. That's a long boy.
It's a long U.
Nice tablet.
It is a nice long tablet.
Yeah.
It's kind of slicey, but
Slicey?
I would said kind of slicey.
What do you think that is?
Well, it looks like Jade, but whether or not it's nephrite or jadeite jade.
Oh, that's a good
question.
distinction, actually. That would change whether it's an N or a J. Put that one in at J and see if there's an N that can replace, just to make sure that we've got this guy in the right spot.
Yeah.
Or find another J. There aren't a whole lot of J's or N's, to be honest. Well, I've been looking at this guy, and it's got me a little confused because it's got like these two zones. One of this like very opaque, like not a lot of light getting through at all, like milky white zone, and then it transitions to this translucent area with, do you see play of color in there?
I do see play of color in there. It's mostly just blue, too.
It's mostly just blue. It's in purplish. It's like reminding me of opal because this opaque side, potch opal, or just regular
common
opal.
Opal.
And this part sort of looks like jelly opal. I mean, does this look like opal to you? Because it's giving me, it's giving opal.
I mean, it looks like opal to me.
Does it?
Yeah.
Okay, that's all I needed to hear. All right. Opal in the O spot.
I'm going to work with this big guy over here.
That's huge.
It is huge. It's really neat.
Good.
But this looks a lot like common opal. So like part of this white part here, but not as quite precious.
That's so smooth.
It's a little smooth.
It's really smooth.
I don't know. It's very interesting. I'll go next. This is a very neat cabochon where if you can see how the light angles it just right, like kind of underneath it, there's some botryoidal habit, I guess. Botryoidal, just like
I see
formation.
What you mean. I think I see what you mean. Yeah.
I think it could be lepidolite.
I don't really know much about lepidolite. I thought it was amethyst.
Well, lepidolite does have a lot of lithium in it. One of the few minerals that contains lithium.
Okay. Well, I know lithium is a very rare element.
It is. It might be the stuff that's reflecting within.
That would be cool. It does have like a reflective inner layer that peeks through in some spots. That's
really
cool. So at first I thought it was rhodochrosite, but it's like too pink. It's too light pink, and it looks a lot like rhodochrosite, which makes me think that maybe it's rhodonite instead.
Well, rhodochrosite can also be these light pinks, but what
That's true.
rhodochrosite doesn't have that rhodonite does have is dark black veining typically, which you can see a little bit on here. It's not as dark as you typically would think rhodonite would have, but I think there's, veining just enough where that is a feature, at least to determine between the two. Lovely R names.
Okay. So this little guy that is right next to our R is very delicate, very light, and I don't know if you heard when it got nudged on the table, but it sounds like glass. And it looks like glass, specifically moldavite to me, because of its big curving formation. It's got like a head area and like a tapered tail area. I'm looking for bubbles. I think I see a couple bubbles. So moldavite is a naturally occurring glass like obsidian, but forms unlike obsidian. A meteorite many yesterdays ago hit the earth with tremendous force and liquefied the ground around it and sent it scattering, flying through the air for kilometers and kilometers. And it was in the air flying like that it cooled off in midair, mid-flight, forming like a head and a tail and a tapered size and the wavy formation. So this is glass that formed flying through the air. It's super cool. And it's also very distinct
really
from characteristics. So I'm going to put that at the M. I was looking at that one too.
It's just so nice to look at.
It is.
Very, very easily identifiable.
As
quartz.
I would say, for bonus points, that this is a Herkimer diamond.
Potentially.
I would say that because it is very, very clear, like transparent. You can look straight through it like glass, which is characteristic of Herkimer, as well as the two termination points on either end of the crystal. That's also characteristic.
It would be Herkimer quartz if we knew for sure it came from Herkimer, New York.
That's a good point.
It's at least a doubly terminated quartz.
Mhm.
So Q's for quartz.
For those of you watching at home, this is a very, very small faceted crystal.
What do you see with your Robert eyes?
I see like there's no fire in this. So I don't think they'd give us a diamond, but this is not a diamond. It's not even CZ, as far as colorless stones that would be fashioned. It's very colorless, but there's like zero fire, and I see some chipping along some of these facet edges, which kind of tells me that it's not the hardest stone.
For a very small stone, there's a slight amount of heft to it.
Really? It's like teeny tiny.
Yeah, I mean,
Okay, all right. I see what you're saying. I'm aware of it. We'll sideline that one. Actually, this is gemmier than I realized. I thought this was opaque, but it's gemmier than this guy. This guy's opaque, but these are a little translucent. That's super cool. I think this is bonitoite.
Yeah.
Yeah. Okay.
Well, at least for those two, there's actually two minerals on those. So the really dark ones are neptunite, but the majority of like these light blue kind of triangular tablets of specimens is bonitoite.
Bonitoite. It's super rare. Basically only occurs in San Benito County, California, and it's the state stone of California. Barely ever forms in sizes above a carat.
Yeah,
and it's hardly ever gemmy.
Very big.
So they're very small and very rare. This guy, neat shapes. So these are very, very, very fine radial needles. You can kind of see them from the side. Sometimes called needle stone, in reference to the formation that I just described, the radiating needles, right? The superfine needles. Yeah. But its government name is naturalite. Did you know that its name comes from the ancient Greek words for soda and stone because of its sodium content? So naturalite goes with the N's.
This kind of also looks very similar to that.
Like magnified?
Magnified, oh yeah. Needly, as
it is needly.
Say.
They're much thicker, larger, more spread out needles, but it's definitely the same. That's definitely a needle stone for sure.
Needle stone.
That's also got a radial.
Yeah, there's a lot of radial fibers kind of going on here, except these are more metallic.
Yeah, they're not needly the way that guy looks like if you poke it, you might get left with something. That one doesn't.
No, they're kind of just not quite smooth, but less pointy, I guess. This is Vivianite. Vivianite is mostly various shades of green. The gem quality is known as
look at this. I've been mentally flip-flopping on this one, back and forth. I think it's garnet. I think it's demantoid garnet. It's got the right shape. I can't remember what, dodecahedron, right? It's got the right color, where it's not like savorite, it's not like mint green. And it's also very lustrous as well. I feel pretty good about demantoid garnet here, about the demantoid call.
We still have a G open.
Oh, we do. Oh, not D for demantoid, because we already have dioptite. Okay, well now I feel even better about it. Yeah, it's super lustrous on the surfaces of these like natural facets. No, these crystal formations are super cool. I'm gonna stop flip-flopping. I'm a horrible flip-flopper on all decisions. That's garnet. That's a rough, really awesome demantoid garnet specimen. Final answer. This
one has a really cool dark metallic base, but I imagine it's the red-brown mineral here that we're
most interested in.
This is actually more tetragonal in its crystal shape. If it's reddish-brown and it's tetragonal, that could at least lead to it being zircon.
I think it's like the oldest mineral on Earth, or at least the oldest rock or mineral ever found is zircon. Zircon is an OG mineral. It's super old, and it's durable enough to withstand all of that time, all of the heat it might have undergone, all of the tumbling through rivers to end up at the alluvial deposit. I know what this guy is. I am familiar with the specimen, I'll admit, but I really like it because it's so clear. You can see all the way through to the back of it, but it's totally scratched up and like appears dull on the outside.
Yeah, it's just a rough.
But then, exactly. But then when you cut it, it just shows this pool of crystal clear topaz. Is what it is.
Nice. This was hiding behind the topaz.
Behind the topaz?
Yep. So what's neat about this tiny piece right here is it might be hard to see for you guys. So we have one termination kind of like pointing out of the matrix here, but if you flip it a little bit more. You see the other termination.
Oh, that
point.
is cool.
I think this could be Eudylite. Any fun things about Eudylite?
Oh yeah, baby. I've got another etymology fun fact for you. This also comes from Greek. It basically means easily decomposable because it's very soluble in acids. You're grabbing at this one like you maybe have an idea of what it is.
There's a lot of, they're not quite fibrous crystals like the naturalite over here, but
No.
there's a lot of
Faces? Like etches? I can see the light reflecting off of it.
Yeah,
is
so like
exposing
instead of
angles and stuff.
needles, they're just more like thin, tiny, triangular sheets in a way. That's coming out here.
Okay.
Could be hemimorphite, depending on its crystalline habit. A lot of the times, it was confused for smithsonite. Hemimorphite can also be a really cool blue color.
Yeah,
almost
this guy's
kind of like these
white.
sticky notes.
These are cool because you've got like these thin, almost bladed, but stacked formations. It's super cool.
But H it goes.
H it goes.
H it goes. Yeah, there's a lot of tiny.
Oof! It looks like it would just break right off.
Okay,
and there's this
sure
little
you
pocket
could.
here. Inosite.
Inosite, you say?
Yeah. So the name for this mineral comes from Greek words for flesh fibers. It's a gross combination of words, I know, but that's because
Love it.
of the color and the shape of the crystals. I'm going to slide it over there anyways because we've eliminated a lot. I think it's telling the ones that we have left.
Yeah.
It's purple. Oh, look at this guy over here on the corner. I just noticed.
Oh.
Yeah.
Huh. It's an actual prismatic crystal.
Yeah.
But most of it is just.
Most of it's very small needles that are like laying flat, kind of like straw on the floor. So I think this is not a mineral or a gem, even though we did find a cool little crystal there on the corner. There's a mineral called camererite, which is named after a miner, a mineralogist, and it fits the description of
Purple K.
Purple. It starts with K. So I'm going to slide this into K.
This one, luckily, does have a label.
It does? Is that our X or our Y?
It is our X.
Xeno time.
Xeno time.
Oh, baby. It's Xeno time.
Actually.
Imagine if the aliens in Alien.
Xenotime, actually.
Xenotime?
Xenotime. I do know that it has some rare earth elements in it.
Cool.
But there's not a lot of X's mineral name.
No, there's not a whole lot of X words. Again, if you thought that there weren't many Q words, wait till you see the X. No. The X wing.
The only
of
other
the Mind Palace. The X wing.
We have
one stone left, and it's a Y.
Yep.
What if it's yttrium and we have radiation poisoning?
Well,
is yttrium colorless and facetable? Really?
I think that's just an element. But speaking of yttrium, which there is a mineral that does have yttrium in it.
Oh, that's cheeky. Yttrium, aluminum, garnet, more commonly known as YAG, because no one has time for all of those syllables. YAG. Honestly, I should have noticed when I was looking at it how clean it is on the inside. It's man-made. YAG is a synthetic stone, and it used to be used in jewelry, but nowadays it's not really used in jewelry anymore. It's actually got a lot of industrial purposes, like in electronics. YAG. I can't believe I didn't think of it when I first was trying to think of Y minerals.
That's fair enough. I don't know. It's not something you would typically think of.
Well, I think we've done our job. I'm impressed with us. We've got them all sorted from A to Z, from Alexandrite to zircon. I haven't had to, I almost said hospitalized. Well, thanks for helping out. I also had a good time. And if you guys had a good time, don't forget to like and subscribe. And of course, ring that bell so you don't miss out on future videos. Thanks for watching.